Today we are joined by Shantanu, and he is going to work through this workshop with us. And if anybody has any questions, feel free to drop it on chat, and Shantanu will answer. Shantanu, I'll leave the floor to you.
So thank you so much. It's super amazing to be here. And I mean, we'll be talking more about what ACI network is. And in this session, I'll be deep diving into how simplified the indexing can be, and what are the challenges that current industry faces in terms of indexing the data on blockchain. So let me quickly share my screen. Okay, awesome. Once again, thank you so much to LearnWeb3 for inviting me, for hosting this one. Super excited. And if you have any questions in between, if you have anything that you want to ask, feel free to drop them in the chat, or feel free to. I'll put up my Twitter as well. So if you have any questions, you can reach out to me on Twitter. I'll also drop our Telegram group, the Builders Telegram group, that you can join in if you have any questions. So yeah, let's get started. First of all, yes. Hi, my name is Shantanu. I lead the developer relations at Hemera. This is my Twitter handle, @thecoderpanda. Feel free to DM me if you have anything related to Hemera, if you have anything related to data. So before we begin, I just wanted to quickly set up some agenda of what are we going to cover today. So we'll be briefly talking about Hemera, what is ACI network, account-centric indexing. We'll be also covering a bit more about what UDFs are and how they are the core essence of the whole ACI network and Hemera itself. So let's do a quick deep dive into what Hemera is. So Hemera is a programmable indexing protocol which focuses on the motto of account-centric indexing. So let's first understand what the whole keywords are essentially. So if you look at the traditional indexers, they focus more on contract-based indexing. So let's first say if I have a Uniswap V2 contract, V3 contract, a token pair contract. I want to know more details about the pools that I've invested in. I want to know more details about the fees that has been involved, and all of these, complex computations or aggregation that is involved while retrieving the data. So when we talk about this part, right, there is a lot of RPC calls involved if you want to, specifically fetch that particular granular part of the data. So there are a lot of RPC calls involved. Two, you have to run like a lot of heavy resources. So one is you need to host a Genesis, from the Genesis node. So it comes up with a lot of costs and computing as well. So these are some of the complex things, and you need to write queries for each bit for a different set of contracts between different set of pools, and even from different set of blocks, right? So that's a huge chunk of data that is involved. So now coming to the main thing, right? So what essentially Hemera does is that it focuses more on the account-centric indexing part. So we make sure that all of the data that's there, all of the data that is being indexed, is focused on the account-centric part. So your wallet address is the key to the indexing side. So we don't focus on the contract, we focus more on the side of accounts. So I'll give an example. So let's say if I want to know what are the liquidity pools that Vitalik has invested in. Now, again, that's a granular part of the data, but I have like a specific wallet address for which I can look out for the pattern. So pattern is understanding the liquidity pool, and I write my UDF, I spin it across with Hemera, and all of the processes get started. So yeah, that's what ACI network is, which is called account-centric indexing. So the job is to mostly simplify the data processing and data access side in the blockchain space. There are a lot of companies out there. There are a lot of tools out there which help you index data. But again, it comes up with a lot of costs. So if you want to extract data, let's say directly from your Genesis node or directly from your RPC node, it comes up with a cost. You have a lot of things that are being involved. And if you're specifically looking for data, let's first say from any other protocol or API, so again, that data is heavily centralized. So there are high chances that the TV might go down or the services might go down. So you might have to look for an alternative. And the other biggest drawback is that you don't really know how authentic the data is. So that's one of the key things that Hemera focuses on, is that we focus more on the side of decentralized data. And I'll be talking more about how are we essentially decentralizing it, and how are we verifying the data side so that it becomes more authentic and more verifiable. So yeah, I mean, traditional blockchains we just spoke about briefly. So three things that essentially covers for a traditional blockchain data access or traditional indexes. One is the inefficiency, high data cost, high RPC throughputs, and a lot of things that are involved. And high cost as well, because essentially when you query an RPC URL. It could be from any of your paid providers, or even if you're running your own RPC node, it requires a lot of throughputs when you put up a cost directly to the RPC node. So it comes up with a cost, and after the cost, let's first say you're dumping all of that data to a Postgres DB, and you're putting up an SQL query on top of your Postgres DB. Again, that's another cost added up to it. So eventually, the cost gets added up, and you end up paying thousands of dollars just to extract your favorite chunk of data. It doesn't make sense, right? Overwhelming complexity. So when you index data, right? So any blockchain data, if you look at Etherscan and any of those block explorers, you see a lot of things that are involved granularly. It's not just a transaction, it's not just a hash. There are a lot that goes beneath it, right? So one is events, transaction logs, triggers, and whatnot, depending on the smart contract, depending on the token, of course. But there are a lot of complexities to extract that particular granular chunk of data. So if I know my ABI, which is my structure of my smart contract, I can just put it out, start spinning my UDFs, and I can start extracting the data. So yeah, we also spoke about what ACI is, but just a quick roundup. So ACI is a programmable interface, programmable semantic interface that we provide. Hemera provides, and on top of it, we have like a set of built-in libraries, customizable UDFs that you can utilize to build your own applications. So some of the key benefits or key real world applications that we'll be talking about. So one is one of the key essence use case using Hemera is block explorers. So we have been providing block explorers to some of the top-notch blockchains. Some of them is Story, Morph, Merlin, Movement, and a couple more of them. So we have been providing dedicated block explorers, and all of those block explorers are proudly powered by Hemera. So under the hood, everything is being run by the ACI network, and what UI that you see is powered by us as well. On the other hand, we also help developers and protocols to build out asset management portfolios. So let's just say if I have like a chunk of tokens that are distributed across chains, I can create a dedicated portfolio manager tool, and I can start tracking my portfolios instantly. Becomes easy. I don't have to depend a lot on the other products. And it could be as simple as Zerion wallet, right? You put up your wallet, just want to understand when the token has arrived in your wallet, and you can create an email alert, so something of that sort. So just wanted to, just a simplified version of it. Identity solutions. So one of the finest examples of this is, so we recently had a partnership with a protocol called Sending Labs. So they use the identity management tool very seamlessly. So they're tracking developer traits. So let's first say if I'm a developer, I wanted to understand how much gas fees I've spent, how much contracts have I deployed, and all of those miscellaneous statistics for a developer's on-chain developer. So they're utilizing Hemera's UDF to track down all the chunk of data. So these are the partners that we have partnered with. These are the official block explorers that we provide, and a few more partners and AI services that we also provide. So yeah, getting started with the UDF. So let's talk more about what UDFs are and how to build one. So UDFs are essentially they act like a programmable logic. They'll act like a trigger that sits on top of the Hemera indexer. So imagine this: the whole bunch of there is a vessel with all the blockchain data scattered around, and we are just dropping down a simple piece of code which is actually aggregating all of that data, chunking it down, and then processing apart. So that's what essentially UDFs do. They extract the data in real time based on the blocks that you provide, based on the data that you provide. And it becomes easy for you to put up your customized logic, put up the data that you want to extract, and it becomes seamlessly easy for us. Next is let's talk more about key benefits of these UDFs. Why do you need a UDF essentially? So one is the whole data query part with the customized logic becomes very simplified. You don't have to depend on an external factor. You don't have to depend on anything else. You write your UDF, you spin it across with the indexer, and that's it. You start getting the data. Next up is with the indexing layer that we have, right? So you can efficiently process all the data at once. So you don't have to create different indexer for different use cases. You can you can just simply go ahead, chunk off your data, put up multiple entities, and get started. So the whole process becomes pretty easy. Exploring pre-built UDFs. So with the UDFs, right? So we have like a set of pre-built customizable UDFs that we already have. That's already public. So you can pick up one of them, build on top of it, customize it the way you want, and start building data-rich applications for your apps. So yeah, this is the list of all the supported UDFs. I'll drop this in the description as well. I drop this in the chat as well. So feel free to have a look at it. Uh, these are all the UDFs that we support currently, but we are planning to expand it down the line with more UDFs and more support for multiple chains as well. Just an FYI, right now at this point in time, we are just EVM friendly. We support most of the EVM chains, and we are actually exploring more synergies with Solana. Down the line, there might be a possibility that we'll be supporting Solana and the other ecosystems as well. Yeah, so let's deep dive. Let's do a little technical deep dive into the UDF components. So the UDFs essentially comprises of three major components. One is models, second is data classes, and third is job logic. So models is essentially are similar to your database models that you create. So any application that you create, may say Web2, Web3, right? So models are essentially the structure that defines your data. How would your data look like? Next up is data classes. So data classes essentially organizes the input and output for more efficient data extraction. So as we were just talking about multiple data outputs, right? So one is your data class defines the whole structure of it. Second, it defines what kind of data that you want to extract. So let's say you want to extract transactions, you want to extract logs, or if you just want to compute a set of logics or set of transactions and pull out a more aggregated and segregated data. You can do that in the data classes. Next up is the core business logic or the core logic that goes in the whole UDFs, and we call it job logic. So job logic, again, all of your aggregations, all of your filters, your all of these methods are essentially called, and you can pull up your all the data from your structured model and start spinning up the indexer to fetch out the data. So we have a 4-step process. I mean, this is a basic UDF that you can create. But for a more complex one, of course, there are multiple factors, multiple things involved. But to create like a very simpler structure of UDF, so first step is to get started with a data class model. How do you want to look? How do you want the model to look like? We'll also do like a quick code walkthrough of multiple UDFs and look at how does the whole structure looks like. Next up is defining the model of the data behavior. How would you want the model to look like? How would you want the data to look like? Next up is writing the job logic. And third is deploying the UDFs. Yeah, so let's talk more about the real world use cases. We already spoke about the Explorer, so I'm just skipping that out. On-chain total graph as well, tracking the data, tracking the developer statistics, and all of those things. Next is DeFi portfolio tracker. So for the particular DeFi thing, right? So all of the data that is aggregated across multiple DeFi protocols, you can create a dedicated portfolio tracker, you can create gas fees tracker, and all of those things using the UDFs. Next up is we have like a filled pre-built API routes that we provide with which are actually packed up with the indexer itself. So you can run your own indexer, you can run your own APIs as well, and in real time when the indexer keeps running, so the API, so you don't have to create a separate backend for it. You can use the same APIs, customize the routes. It's built on top of Flask, and you can start retrieving the data directly from the DB in which it is stopped. So essentially, another thing that I forgot to mention is that the Hemera indexer, it comes packaged with a Postgres DB. Feel free to ignore it as well. You can use multiple outputs. So one of the essential outputs is that you can export the data to Postgres, and through Postgres you can connect to the APIs and start building wrappers on top of it. Next up is how do you contribute to the ecosystem? So we are very new. We are just getting started. We are already powering like a different set of blockchains. We are powering more data services to indexing services to broad range of protocols. But if you're a dev who's interested more on the data side, who's interested in helping the whole decentralized data ecosystem grow, so we have like a set of things that you guys can follow. One is documentation. We're still working on the documentation, and if you feel that you have some more feedback and that you want to give, feel free to raise a PR, feel free to just drop a mail or a feedback on the Telegram channel. You can write your own unit test cases, because more the UDFs, more extensive testing is required. So yeah, feel free to write your own use cases. Feel free to write your own test cases and drop them up in the chat. And if you're coming across any performance issues when you run the UDFs or when you run the Hemera indexer, feel free to let us know. And finally, the use cases. So we already have a builder group which is building like very exciting use cases, and some of them, one of them is actually a meme coin tracker, which is very exciting because I can see like cross-chain meme tracking it can be challenging, right? And if you need some specific alphas, you need a lot of data, and if you need the model to be trained on top of that alpha data, again, it takes a lot of time. So to counter that part, so uh, one of the engineers is actually building a meme coin tracker, and it's pretty interesting. So it might be out anytime in the next couple of months. We'll share it with the community for sure. And yeah, these are some important resources that you would want to look at. One is our official GitHub, and I'll also share these links in the description. So feel free to have a look. And if you have any questions, feel free to reach out to me at thecoderpanda. So yeah, that's it from the whole theory side. We'll do a quick walkthrough of the code as well, and I'll come back to this slide again. Okay. So yeah, so there are two windows right now. One on the left side is my code, and then the second side is a terminal that we'll be trying out. So I've been working on the Uniswap V3 use case, but yeah, I'll be explaining one of the very simplest one to you. Let's go to demo jobs. So all of our code for the UDFs or the user-defined functions lies under the indexer folder. Inside indexer folder, you have a module folder, and inside module, you have a custom folder. So in that custom, you can see there's something called demo job, which is a very basic instant of how to build a UDF. So inside that, you can see there's a file called demo job, which is essentially a job filter of the job logic. Before that, let's go to domains, and let's first understand the data models. So this is our data model. So this is data class, my bad. Sorry, this is our data class, and this is how it would look like. So you're basically defining how the data structure would look like. So I have a data, let's first say I have an array of data, which is the ERC20 token mint. And I would want the characteristics to be defined in a certain manner. Let's first say the address needs to be segregated, a token address, the token ID, block number, timestamp, hash, log, indexings, and all of those things. So I need all of these to be structured in such a manner so that I can segregate the data, or I can actually read the data clearly. So that's how data classes are. So you're defining the data, and you're just passing off an argument filter data, so which essentially filters out all the data part, all the data chunks, and yeah, this is how the data class would look like. So this goes under the domain folder. Next up, let's look at the data model. So data model, again, this is more on the SQL side. So if you're not using Postgres, if you're not using a database to dump your data, feel free to ignore this. You can just omit this step. And yeah, as an output, you can, if you want, you can also export the data in JSON. You can export the data in TXT files, depending on the use cases. So in our case, we'll be using Postgres to do that. So to make that happen, right? So one thing that you need to check up is this one, right? So which is the ERC721 token mint. So this is the table address, or this is the table name that we'll be putting up in a database when the indexing happens. So when the indexing happens, the job is completed. The data will be essentially outputted or exported to this particular table in the structure that we define in the data class. And if you see here as well, this is the organization of all the data that we have. So we are actually defining the ORM, which is essentially used in most of the applications. We're defining an ORM, we're defining a structure to our data, and then exporting all of that data when the job is done. So yeah, this is the class that we have. This takes care of everything that we need to make sure the data is exported successfully to a database. Let's come to the final show, which is the job logic, or the UDFs itself. So if you see, we're essentially exporting two things. One is we are exporting the logs, because we want to read the logs of a transaction, and then we are also exporting the token transfer data class. So these are some predefined data classes that we have already defined. So the reason why we want token transfer is because we are actually tracking tokens in this demo job. We are tracking tokens for ERC721. So to understand how it works, we are actually creating this part wherein you can track down all the data. So this is the data class that we are importing. Next up is base job. So some of the base operations that we want to have that we want to happen. One is collecting all the transactions from the indexer or from the RPC itself. Next is filtering the transactions based on the logic that we provide. So yeah, so this is another very important thing that if you're writing in EDF, you should not miss. Some custom data classes. So one is we have our own data class that we defined the domain, the ERC20 token with. The structure, we just imported it. The other is specifications. So what kind of specifications that you want? So one is I want topic segregation, and I want transactions filters by log. So I want to filter all of my transactions by set of log instructions, and I'm actually importing that data class to do that operation for me. Next up is, of course, the ABI. This is essential because we are actually tracking down everything from the RPC itself or from the RPC node itself. So to make that happen, we need an ABI because it's actually tracking down all the structure of the data that we are chunking out. So an ABI is required. So to get an ABI, it's very simple. You can just go to any of the block explorers, put other contract that you want to track out, copy the ABI, put it out in the API, in the folder that you can see here, ABI underscore setting, and just give it a class. That's it, and you can you can import it. So it's as simple as you can change this as well. If you want more specific to ERC20, you can change it, import it here, and you should be good to go. Now let's talk more about this particular function, which is filter ERC20 function. So what we are essentially doing is we are listing down, or we are actually creating an array of all the logs that are fetched from the RPC node. And then we are creating a for loop, and we are actually getting all the signatures and tracking down. And if the data is fetched from the genesis, which is zero address, which is 0x000, which is the genesis address or the address from which the node starts, or sorry, which the blockchain starts itself, or the as you can see, right? So that's what zero address means. So if that is decoded from here, so which it omits all the steps, or else it appends essentially the data class into this structure. So all of this data is then catched out, fetched into it. The data structure is put in, and then it is exported to a database. And once that's done, the token transfer is returned. So yeah, that's how the function is. This is a core function of our data job. This is how it would look like. Now let's understand a bit more about what we are trying to do here in a deeper sense. So one is we are calling this filter transaction data job. So this essentially, again, filters all the transactions by particular data set, and how do you want to have that happen. So you're actually calling that particular data class here in this particular customized job, which is demo job. And after that, you're actually defining the initiation function, wherein we are initiating the contract itself, from where we want to fetch the data. So it could be different from different cases, right? So we're using a BAYC1, and you can actually hard code it here as well, or you can define it in a config YML as well, depending on how you want to do it. And after you do that, we have a get filter thing, which is very important because we want to filter out transactions based on your contract list and signature as well. So this API has a parameter called get signature, which essentially filters out things out for you. So you're specifically looking for that particular contract that you have given out in the kind of config file. And for that, you're actually looking for a topic, which is array of topic, which is your ERC20 transfer event. And underneath that, you have your signature, get signature. After that, you're essentially returning all of that data. And then you're defining the another UDF. So this processes all the input output for the collection. You have all the data. I mean, these are just some generic notes that we have made so that you know what it does and how it processes. And once that's done, what we do is that we call out this function, which is filter ERC20 min. So in the demo job class, we are essentially calling a parameter which is called filter transaction data job. So this particular thing, this particular data class is implemented to fetch out all the transactions from an RPC node. And we need to perform specific or customized logic on top of it. So that's why you need to call that out. And we're creating a separate class called demo job. Inside there, we are essentially initiating the contract. So there you go. We have a list of contract that we want to index. I have a single one as of now. And all of these things will essentially go under this config folder. And then this you have like set up, this is the one, right? So you just call this out and yes, you should be good to go. And the next step is get filter. So you're essentially filtering out all the transactions based on your logic. And once that's done, this is just the output collector that we are creating. So if you look at it, right, the output, which is collecting all the data from this particular output. And then collector is essentially exporting that data or structurizing that data in the data class that we have created. Once this happens, all of this is now filtered out again based on the logs, and then output is collected to the database. So that's how the whole UDF structure would look like. And to run an UDF, you have two different ways to do that. One is through Docker. You can easily install Docker on your system and get started on top of it. But if you're doing a development, what I would recommend is run it from source. And to run it from source, you need one thing, which is Python 3.9. And if you have it, just go ahead, go to your terminal and type Meet Development. So this will essentially install all the recommended packages in your local system. And once that's done, just go ahead and quickly activate your virtual environment, and you should be good to go. So this is one of my examples that I was trying to do for my Uniswap once. I'll just quickly show you how to do it. So there are a few commands that we have, and we can just run it. So it will essentially run through all my indexing jobs. It will take a few minutes, and all of that data will be then chunked out into my database. So I've connected a few databases, and all of the magic happens directly on my system. So I don't have to rely on anything else. Things happen. So yeah, it should take some time, but yeah. Meanwhile, if you have any questions, feel free to reach out to me. Feel free to drop them in the chat as well. Yeah, I mean, parameters are a little odd right now. I need to check. But yeah, if you can see the extraction is happening right now. You can see the name of the tokens. You can see the name of the symbols and all of these things, right? So if you see the address is also being fetched out. So all of this is happening directly from the indexer, and this data is being then exported to the database that we have right now. So let me just about this. So yeah, this is how you run it. And yeah, I mean, simple as that. If you have any questions regarding Hemera, if you have anything specific that you want to chat more about, feel free to reach out to me. I'll also drop the link to the builders group. Feel free to join the builders group. We have some really OG builders out there. If you have any questions, they can help you out, or I can help you out. So yeah, that's it from my side. I'll just quickly share the Discord handle as well. So if you want to reach out to me, talk to me more about Hemera, feel free to reach out to me on this handle or on Twitter. I go by the name The Coder Panda on social medias. So yeah, that's it. Thank you so much. Thank you for hosting me, LearnWeb3 folks. Thank you, Sohail, for having me here once again. Thank you so much. Cheers.
Awesome. Thank you, Shantanu. Also, I wanted to give a quick shout out to Hemera's mini that we recently launched on the platform. So if you want to learn a little bit more about Hemera, make sure to check out their mini on the LearnWeb3 platform. And then we'll have all those links that Shantanu provided throughout the workshop down in the description below. So thank you again, Shantanu. Hopefully we host more workshops in the future. And have a great day, everybody.
Yeah, for sure. Thank you so much. Thank you for having me.
Thank you.
Great day. Bye.
You too. Bye-bye.